California. You're about to see the world with new eyes. The veil of haze and fog will be lifted, and you will behold the flat earth like never before. But before that, let me show you how I got here, because it's been quite a journey. Back in January 2016, I clicked on my first Flat Earth YouTube video out of curiosity, and I was hooked. I bought a camera and headed to the beach. This was my first photo that got me thinking. I took pictures of distant islands from Santa Barbara and started doing calculations based on known reference points to see if they appear at the correct elevation. I've done a lot of imaging of oil rigs to see if the curvature of the earth hides them at all. Lots of thinking over 2 years. I began to realize I need to see through fog and haze, because at the coast it's usually hazy most of the time. I got into infrared photography. This is a 720 nanometer filter for my DSLR camera, and I was impressed. It seemed to work better than visible. I even headed out to different places to explore the flat earth. This was Salton Sea in California. The water was very calm and I could see very far. Then I went up north on a trip and I was in Idaho. And this is Lake Pandoray. And I was able to see a boat way in the distance. Slowly I began to realize that there is something to this flat earth movement. This is Lake Tahoe here, 18 miles across the water, and I could see the casinos. This was highly fascinating, but the next experiment really got me thinking. I was flying from Buffalo, New York to Chicago early in the morning, and there was glare over Lake Erie, and I could see way in the distance. I was testing out the notion that the horizon rises to eye level, and using a app on my phone that takes advantage of the inclinometers, I placed the crosshairs down at about negative 3.3 degrees, which is where the horizon should be from that high up in the air, yet I could clearly see the lake. This was really something else. I really got hooked on this flat earth. I set out to prove to myself that it's refraction. Refraction must be what is causing this flat earth phenomena. I started studying the mirage over water, and the closer I looked at it, the more disturbed and perplexed I got. Light seemed to be bending upwards, not downwards. Initially I thought the reflection is off the surface, but the surface is rough. It can be off the surface. Then I started reading different papers and I realized there's a evaporative boundary layer. I began to realize that the shallower the observational angle is to the surface, the more prone it is to refraction in the evaporative boundary layer. Beyond a certain critical angle, there is a lot of bending of the light rays. That's why when the flat earth researcher looks out in the distance, the angle becomes shallower. Based on this new insight, I decided I need to sight objects over land and really tall objects like mountains, so the angle is somewhat steeper and I can minimize atmospheric refraction. And to see as far as possible, I started using infrared, which can pierce the fog and the haze. Now have a look at these videos. Like we're just there in Malibu. Let's see what we can see here. There's a light right there. There's a light. There's Santa Monica. Now have a look at the invisible world. It's a gorgeous day. I'm gonna go walking on this trail right here. Here we go. I'm in position and I'm pointing the way towards LA. And there you have it. That's LA with the San Gorgonio Mountains in the distance, over 100 miles away. Incredible. But wait, there is more. Look at that. That in the distance is the ghostly figure of Mount San Jacinto by Palm Springs, over 117 miles away. I'm panning to the right, and there is another mountain peak that's visible. There you go. That's the LAX control tower to the right. Just incredible. That peak is over 70 miles away. This is just incredible. Look at the difference infrared can make. It can reveal the unseen. The perfect tool for researching the flat earth. Let's have a look at the map to see what we saw. There's 3 lines there, and those are the peaks that we were looking at. Very far away, incredibly far. But I wasn't pleased with the resolution, so I embarked on another project, a high-resolution imaging project. I bought a Celestron spotting scope and a monochrome astronomy camera, and I put an infrared filter in front of it, an 850 nanometer infrared filter, and it worked pretty good. Have a look at this. Look how I can zoom in on an area. That area in infrared was 3000 by 2000 pixels, high resolution, and I could zoom in. This was the island visible from Santa Barbara, but soon I went to Malibu again. Have a look. Wow, just look at that. Wow, behold your flat earth, folks. Let that sink in. If this doesn't move you, perhaps math will move you. In the next slide, I'm going to show a scale. I finally had the resolution I needed, and I could create a scale based on one of the buildings in the foreground. So based on the building you see in the foreground 12 miles away, I now had the resolution I needed to see the floors, the different floors, and I averaged a few of them together and I assumed about a 12-foot separation between the floors. And based on that I created the scale in milliradian. And wouldn't you know it, that mountain not only is visible when it shouldn't, but it's showing up at the correct angular elevation. Simply amazing. Now, if the Earth was curved, we shouldn't see Mount San Jacinto, even though it is 10,600 feet high. The shoreline and the hills on the other side of the bay should be hiding it in entirety. Now if we compare this to the flat surface model, look how simple it is, and it is accurate. We calculate the correct elevation of 17 milliradians. Simply incredible. Now I'm gonna leave you with these images. Just ponder this, folks. This is incredible. That's all I can say. Incredible. Behold your flat Earth, folks. Just incredible. This picture was taken from even farther away. I went to Point Dumay, 122 to the peak. The peaks to the right, 125, and even farther away. Just incredible. The ghostly image of distant mountains, bearing a silent witness that the Earth is flat.